This time should work. I think I don't have any lucky to see log message. Last time, the same situation we ended up we are checking the log of an activity which gave a wrong results. This time also. Something it's throwing some error, I remember. Unable to start service intent. Okay, let me see. It's kind of some sort of code these guys are writing. I really don't know. Going to set to enabled true. Okay, maybe. Okay, I think I need to add enable true to set the service. Maybe it's been made pretty strict nowadays. Start the recording as well. So make sure you set the service set to enabled. And in fact, you don't need to put that at all. I'm going to see whether I'm going to remove all those additional setups. I'm just going to declare the name of the service alone. I think the by default one is set to enabled. Let me run one more time. Okay, so make sure you put it either enable set to true or just don't define anything at all. So now when I click the start button, in the log I'm getting service started and running. I'm going to keep clicking the start button. You notice nothing happens. Once the service started, it's one time started and any attempt to again starting the running service does not take effect. This kind of a course, which is safer to call multiple times, still run only once, these kind of a codes are considered thread safe. They won't create a duplicate process IDs or every time when you click on or try to start it. So only one process which is already started, so any attempt to start the service again does not recreate or does not destroy it, doesn't do anything, simply just reject your attempt to start the service. And the stop will stop the service, and hitting multiple time also it doesn't throw any errors. So once the service started, it can be stopped, and stop service, any attempt to again stop it of course would be rejected. Now I can start the service again and stop it in number of times. Okay, When the service is set to start, when I close the application, the service remains in the background and it runs throughout. How do I find it? I have no idea whether the service is running behind the screen. There are a couple of ways to identify whether the service are running behind or not. Uh, One is writing something, a small timer inside, see whether how long it runs. And the same I can write in activity also. So how long the timer runs in activity, how long the timer runs in service will give a clear idea about which one is running longer. That's one idea. Second, using your device to identify whether something running behind the screen, clicking settings, should be apps. I think somewhere I usually see them are running, I hope. If you see this, my service example has one process, working process, nothing but through one service. This guy is running behind the screen. So this will give you an idea. So which one is actually running behind the screen? This can be stopped, terminated at this point also. So this is actually not recommended because any attempt to stop some sort of running process may give you a kind of an issue where which you did not expect. In fact, Android also tells the service was started by its app, stopping it may cause app to fail. So of course nobody is going to do, but at least I can identify such a service is started, it's running. See, if you see the time is being incremented, it's been running from 1 minute 40 plus seconds, so it will be running throughout. So I'm going to assume the service is running. Let me stop the service. Okay, I got a confirmation in my log as well. My service stopped. Very close, going to settings, apps. Where is this? Sorry. Here I don't see any entries about my app. So the running processes does not contain anything. So my service is could be assumed it is safely stopped. Okay, but we'll do some sort of a nice example. Instead of seeing through the phone settings, what if I'm not writing the code for a phone, if I'm writing for some other device where I may not have these settings? So we'll have to programmatically find whether the service is running or not. So let us do that one. I'm going to write a small thread, timer inside, so that the timer, how long it works. A timer need a wrapper so that the separation block and starting and stopping using that block is helpful, that such a separate block or handler and a separate running block this way also I can do. Otherwise, there's one way to do this. This thread I'm creating only to create a timer, not for a delay purpose, because this particular service itself runs behind the screen. Okay. A handler, just like a Java, it's going to help you to call a background process or a thread. But the thread, when it will get executed, I really don't know. So what I'm going to do, whenever the service started, the handler class will call post delayed. It has a argument which require a runnable block, a separation block. In this case, it has been implemented over here. How long you want to call after some delay? So 1000 mean 1 second. 1000 millisecond in 1 second. So after 1 second, it will execute the separation block and execute whatever lines you write. Here I'm going to write okay, I can write something. Called in 1 second, something like that. So I'm going to recall it again after a second. Handler is an indefinite loop. After 1 second, again it will call the same runnable block. Again 1 second, keep calling. So it will end up producing a kind of timer 1, 2, 3, 4 on every occurrence. So this handler will call the separation a threaded block after 1 second. Once the particular block execute the lines of code, again it is going to call the handler with the same 1 second delay and keep calling. This code will roll until the service lives. If the service is not there, this thread will be killed. But for a safer side, I can also undo remove callbacks. This is safer. So I'm just making so whenever the service is destroyed, stop the thread also, which will avoid your memory leakage errors, because as I know the destroy is the endpoint for my service. So that the thread also will be killed. So how long it runs, by seeing the timer I can identify whether the thread is running or not, or something background working or not. So this handler is a class, special type class. It can initiate a separate process. One. Second, it needs a separation block or separately running block called runnable, so that it transfers the control to that block and executes. But unfortunately, the runnable has an abstract method, nothing but the callback method, because it need to tell I am done with the work. So that callback method is called run. So when the particular end of the line is reached, this code will transfer the job back to the what do you call, in this case, service. But from this example, what I come to know, whenever the thread completes the job, it again starts with a delay 1 second. So the thread is going to run throughout, but it will run only up to a time where your service is allowed to live. You see? You notice the thread is continuously printing something. Every 1 second, the code is being executed. It's running. Let me close my activity. It still runs. The application no more visible, but still runs. No idea my application, whose application, I really don't know, but that particular service is doing the job without any interruption. You can very well play the music player, you can go to browsing, you can take a picture, you can do anything, but still that particular service will be running throughout and will be doing the execution in the stealth mode, in the background. So it will be continuously working. Okay. Is that, if I really need to stop it, I have only one way to stop this. Okay. Start will do it from the beginning. So it very clearly tells when the destroy is called, the service entirely destroyed and it lost all the variables, whatever it was having, it lost and starts from the beginning when you click on the start button. Okay, now the thread is, this particular service is running and putting a delay using a thread. I can safely click it multiple times. It still does not get disturbed at all. So it is still a thread safe. No one can disturb the job of the service which is currently doing. And anything happens to the activity which actually started the service, it doesn't matter for it and it still runs throughout. Stuck. So it's a pretty nice example as my service is running behind the screen. What if I put the same timer here in activity? Let me also put the same words. Okay, this time I really want to. Okay, the filter is added using the tag. No problem. Stop, not to get confused with our activity lifecycle method. Okay, so we'll put a timer here as well. Handler is a special type. It's equivalent to thread, the word thread, which gives you a option to separate your logic. So a handler is a kind of a caller who can transfer the job to somewhere else, where it is actually transferring somewhere in a runnable block. The runnable block does not have any working method in this case because we only add a delay. So it may be doing something, I really don't know. But after some sort of delay, when it completes 1 second, it gives a callback through a method called run. So that's what it does. We are not doing anything physically, in fact, but we are just separating the logic. If you notice the handler, that import, if you notice, it is a special type method which is exclusive for Android, because any running process accessing a thread, trying to terminate, trying to add a delay to it, is going to cause some sort of performance specific errors. So it is better to use a handler for our thread purpose in Android. Okay, so I'm going to do the same here. Let me put some different color warning. I'm keeping the same tag because I added a filter using that tag. So what I give called. Instead of D, I'll put warning. It will show me in a different color. So activity started, stopped, and it runs. The same code I've written over here. So we'll see the time difference of an activity and the service. It runs most train. Okay, now activity started the job because I have written that immediately as my activity become visible, and it has started executing, and the activity is printing the what call that I position, like every 1 second it is incrementing. Now I'm going to start the service, and both the guys are running different processes, but both being printed. Of course, each have their own timing, and of course each run in a 1 second interval. Now let me minimize my code. Both runs, which is an expected behavior because I've just hit the home button. So I'm pretty sure my activity is simply put into background mode but still running. Go back. Works. I'm going to hit back button. Now activity lost the timer because the activity is no more. So it could not print anything because it has lost it, the thread also. It has lost this processing cycle as well. So activity, that thing which you wrote, terminated. But whereas this guy keep printing and going ahead. It may start working when I open the activity, and then it will freshly start the job. But the service, as if it is working, it doesn't know anything, or whatever happened to an activity it doesn't know, but still it's doing the job. So by this calculation itself, we could easily come to a conclusion: the service life cycle is pretty longer than the activity. Activity life cycle is limited with the user influenced actions. The user anytime can hit the back button, or phone call comes, or something goes on, the activity may get destroyed, and it may not live a longer time. But whereas the service, since it is entirely in the background, since it does not have any way to stop it through a user interaction or user button clicks or anything else, uh, it runs throughout. So we can easily arrive at that conclusion. And of course, if I stop it, that will stop, and this guy will continue to print, and I can see it. So both the thing destroyed. So we do not have both the processes running. Remember, I use this handler to produce a delay. It is nothing connected with the service itself. The handler or a separate thread can be used anywhere in your code, be it service or be it activity, be it broadcast receiver. Just separate your code logic to somewhere and execute the job and comes back. So this handler is a thread, and of course it can execute in a separate process but still wrapped within the life cycle of either an activity or a service. But whereas the service is a dedicated background process, once it reaches to a running position and keeps running until it is manually put into an end. So that should be done through a intent or some other action performed. So this is very clearly gives us an idea to call a service and do some sort of work. Okay, so this is an example of a service as we know. But whenever the process thing comes into discussion, we will always get into a troubled scenario. How these guys can communicate each other? Okay, since you safely printed the message in a log, I want you to print the log message which is generated in a service. I want to show it in activity. That increment I 1 2 3 4, I want to display in activity, but still it should be running in the service. So how I can take the value I to a activity? A slightly difficult job, because these guys are running their own processes, and inter-process communication is not something so easy. So that's why I gave a scenario to imagine two running processors, mean two running vehicles or anything else which is doing in their own speed, cannot communicate each other because they are doing in a differential speed. So a train doing 100 miles per hour and another train doing 200 miles per hour, no one knows, even it may be doing opposite direction. So communicating between them is a tedious task. So similar situation we have ended up. This activity, main activity, runs in its own process, whereas the service runs in its own process. And this guy has its own life cycle, and this guy, the my service, has its own life cycle. I really don't know what ways these guys can communicate each other. So how it is possible? That's where your broadcast receiver come to rescue. A broadcast receiver can also be used to broadcast or receive a message. One side it can do a broadcasting job, another side it can capture, receive the message. So obvious thing, service is going to broadcast something. Where your broadcast receiver, where you are going to write inside the service, which is going to broadcast a message. The same broadcast receiver which you are going to write inside an activity going to receive it. So two different parts, so that broadcasted message is captured irrespective of the differential speed. That's what uh, we really don't know. Uh, Assume your FM station, we really don't know where it is. But this guy is speaking something, your radios or anything can easily pick it up. You may be running, you may be sitting, you may be somewhere else, but still the message is being picked. It is possible through a broadcast receiver like your antennas and the receivers. Similar scenario we are creating here. You have to imagine yourself, yes, assume, yeah, two different trains are running. Somebody is loudly crying or loudly speaking, yes, these guys can capture it. How it can capture? If it knows from which channel the particular message is coming. Uh, Obviously, I think you can imagine the radio itself. If you really want to listen a particular FM, you need to tune your radio to a specific frequency to receive or to get the signal. So similar a virtual scenario we are going to create here, so that a message is broadcasted from a service going to be captured or received in activity, so that I can transport a data from. In fact, this is not an ideal situation, an ideal way to transport and receive the message, but somehow it adds a flexibility to communicate between a service and an activity. It gives me an idea. So let me introduce one more class called broadcast receiver, how I can do it. Let me see. A broadcast receiver can be written in two ways. One as a standalone class, like right clicking, what do you say? So this is there, activity folder fragment. It's not there, of course. You can still write it as a separate class, or as an inner class also you can write it. I'm going to do the inner class now. Before that, let me adjust my UI so that I can display the numbers being printed from a service. And also I'm going to encounter a different scenario as well, because a service which is continuously printing something, whereas an activity that time may be open or closed, I really don't know, but still I want to display the values coming from a service. So how I'm going to do, maybe when activity is just created, it tried to get a communication to a service and get the latest value of I and continuously listen. When it get destroyed, remove the connection. So in that way, it is slightly possible to achieve the a particular option. But this time, I'm going to use a broadcast receiver to do the job. So before that, I'll adjust my layout so that I can use my broadcast receiver to display the value. I'll put a text view in between. A21 XP textile placeholder text. I'll put something. The app name itself. Layout gravity will try to put the layout itself to a center, but it is highly irrelevant here because the layout has already occupied the entire width. So that just the gravity will do, the text alone could be put into center. Okay, here this I value is going to be displayed. To start with, just a text. Let me initialize. Okay. Time to create a broadcast receiver. I'll give a name, my receiver, some name. I just declared I need to have it initialized. In fact, it is a class. It can be globally also initialized. I think I'll do one thing. I'll globally initialized. Yeah, but this will do. You can locally also initialize, it's up to you. But because I am going to need this global space so that it can be subscribed or unsubscribed, mean it can be added to a particular intent filter. As I was talking about, intent filters are nothing but a strings, a unique string. Make sure it is not being used by some other codes, and it becomes a channel for your communication between the broadcast and the receiver. Means you virtually assume you are establishing a radio station. So what you will do, it simply go to the department of broadcast and receiving, or some sort of department will be there. They will allocate you a frequency and they will dedicate it for you. So anything you transmit within that frequency, anyone who is tuned to that frequency can get your message. So this is a simple radio, communication engineering process. You guys are already engineers, so you may be knowing it. So a similar situation I need to create here, so that I establish a medium or channel so that a broadcast receiver can either broadcast or receive the message through it. I usually give some sort of unique combination. Try to say it is always unique. It just need to be unique. That's it. So no one, my understanding, no one would have taken this. So this is a channel name. Okay, as I created the broadcast receiver class, once I try to initialize it, if you notice the one and only lifecycle method of my broadcast receiver method has got implemented, which is called onReceive. This is the only method it is going to execute. Once it is executed, that particular method it disappears. And it has two arguments. Thankfully, both the thing are quite important. This is the context. It knows who has sent the message. This is the intent. So it can carry the payloads, bundles from it so that I can get the data. course I'm going to use them to get the values. So maybe the bundle stuffs are there. I need a key if I'm using bundle. I just used it. So standard one to intent get extras. It is always a better practice to check whether the bundle is not empty. Assuming I'm going to receive a message, an integer having a key MSG, and that I value I'll be capturing over here. This I want to display in this text. I need it as a global now. When you are using integer, should be very careful. Because this is a text view, only accept a string. If you try to put an integer directly to a text view, it will try to search in the resource folder. So to avoid it, I need to make sure okay, that's been done. Few clarifications still. This text view is being initialized in onCreate block, and this broadcast receiver is already initialized on the top itself, but I am still calling the text view safely because assuming the broadcast receiver will be attached only after the text view is created, so that I can safely call this message object safely. I'll let you know what I'm trying to say. Intent filter, creating my own channel. Action. This action itself, your filter message. Okay. The register receiver, my receiver, and the intent filter. Remember, at this point only your broadcast receiver gets registered with your activity. So then only this class will start running. I am registering the broadcast receiver well after my text view is created. So here only the broadcast receiver will start working. So at this time my message would have been initialized and it will be ready to capture the message, which is whatever it is receiving. In fact, it yet to receive any message. I just wrote a class which can capture any message wherever the message is transmitted using a keyword MSG, but I yet to define it. Okay, and also I need to make sure and register my receiver when my activity is no more. This is to avoid memory leak again, because the receiver should only work whenever my activity is alive, and not necessary to have the receiver always connected if my activity is no more. So it is not going to update anything on my text view. So This is a safer one, better practice. Now let me transmit the message from here. Where the I value increasing here. The receiver, the channel also we need to attach set action. Send broadcast. I'm not going to set result because it has nothing to do with the activity. The same approach, but this time the put extra and after that an action being set mean this is a channel and broadcast your message. So this intent payload will carry an extra message having I, and it is transmitting the message through one particular channel called my filter, and the broadcast being done. It will be done in every 1 second according to this code. When the broadcast is done, this activity, if it is registered with this receiver, will capture it anytime when it receive a message, because this receiver is listening the same channel, my filter. So one guy is transmitting a message to a channel and the second guy listening the channel. Of course, he is going to capture it. So this is the broadcaster job it is doing. This is where it is doing the receiver job. So a broadcast receiver, it's a two-way part. One side a message being broadcasted and another side the message is received. So the broadcast receiver having implemented in the both the side, one side it is doing the broadcasting job, on another side it is doing the receiver job. In knowingly or unknowingly, it is doing the connection job as well. It is bringing the data from a different process to another process. So let's see. I think I don't need this now. Okay, start. If you notice, the values are coming here. The same values being which is getting printed in the service now brought into an activity and getting displayed. It is mean your broadcast receiver doing the job. One side it is broadcasting the message and another side it is capturing the message and giving that particular value to a text view and keep updating the text view as it receives a new message. The new message will be available every 1 second because this is how we wrote the code there. So a small handler, a thread has a small delay inside, mean 1 second delay. Every 1 second it updates the number called I, and that's getting printed over here. This will continue. In fact, I can safely close the application also. I think somewhere around 43 I close my application, I remember. So under our assumption, the service will be still running and maybe incrementing the I value anytime. So now I'm going to open the application. I still get a latest result because when I open my application, this activity again tried to connect with the same broadcast receiver and got the latest number this time, and of course doing the job continuously. So this is where we added the register receiver and unregistered receiver. So in a very first time an activity created, I register with the receiver so that it start listening to a particular channel called my filter and keep receiving the messages. When message keep coming, it will update the text view. And when activity is destroyed no more, what is the need of this broadcast receiver? It can also get killed, but let the service continuously broadcast. Whether, for example, if a radio station continuously transmit a message, even though all of your listeners are turned off their radios, what it does matter, it doesn't know. So they will simply broadcasting it. So similar to this situation, this broadcast is continuously broadcasting the message. Whomever listening it will capture it. Nobody listening it doesn't matter for it. So this particular scenario, we emulated the entire situation of a broadcaster receiver. But in a real scenario, you may be only doing the broadcasting job or the receiving job alone. For example, the broadcasting job maybe the system would be doing. For example, your SMS. Your system already has a SMS manager class which capture the incoming SMS through the radio signal. So the particular receiving job your system is already doing. You will be only notified as if that particular message has been received. You will only be broadcasting. The system will broadcast the message you may be receiving wherever you want to display it. So half of the part you may do, half of the part system may also do. So it's up to you. But in this example, we have written both the parts, where one side we do a broadcasting and second side we do a receiving part. So this is continuously doing the job. So app can get closed anytime without any worry. When any time it is open, it will start from the very first. Now I can stop it. As we know, it simply stopped over here, but when I try to start it, it will start from the beginning. So this is how the service is sending the message to this activity. So this is a simple example of all the three concepts of your Android learning program. One, we created an activity. We know the activity lifecycle and its timeline. And we created a service which is a longer lifecycle one, and we put a delay timer there, and we found it is running independent of an activity. Even though an activity start the service, but it still runs independently. Third one, we encountered a scenario where we need to communicate both the guys, like an activity and service together. Any data which is printed in service should be taken to an activity. In this case, we introduce a new class called BroadcastReceiver. So one side it is doing the broadcast, and another side it is doing a receiving job, and it through a IntentFilter, which is a unique ID, so that through the channel it transmits the message and being captured. If you implement in back the opposite direction, mean broadcaster in activity and receiver in the service, we need to do the opposite job. So a data can be taken from an activity to a service. This is one of the easiest way of communicating between the interprocess. What do you call interprocess? It's not an activity or service. I cannot differentiate. That's what I'm trying to say. So it's best simple way of communicating interprocess communication maybe. But there are plenty of other ways also exist. The negative side of a broadcast receiver may be anyone who knows the IntentFilter can capture your message. Not only your application, any other application as well. A broadcast receiver is a centralized daemon process where the message is broadcasted from a kind of a source. So if this filter, if it is big, if somebody understood, okay, this is a filter. Assume the Facebook has a broadcast receiver. You somehow come to know about the Facebook broadcast receiver. What will happen? You will capture message. You can write as another application, capture the new message and send it to somewhere else. It becomes a potential violation of your security issues if the broadcast receiver IntentFilter is known to somebody else. But there are ways to protect the broadcast receiver, a private one, so that the broadcast message is captured only within your application. You can still make it by defining some condition in manifest. That is also possible. And that in that case, the broadcast receiver only works within your application. None of other application can capture your message. So we have to do an additional steps to make sure our application is secure if I'm using a broadcast. So that in turns on side a positive and as well as a negative side of my broadcast receiver. Second, it is not pretty clever. It helps me to communicate to and forth between two different processes. But uh, what if I need to communicate, call a method, a function defined in a service? I want to call it from an activity. This guy may not be an ideal guy, because it can only call certain things, but I need to have various bundles and various additional data to differentiate the control flow to somewhere else. So may not be that much so clever or something, like it understand the queue and accordingly it process the inter-process communication. It's simply doing the broadcast receiving technique. But for an ideal condition, you should be connected with the service and you should join in a queue and then communicate the service in a proper way. So that's a ideal way to communicate a service and an activity. So in that case, we may need a messenger or AIDL to do the job. That's an additional or an in-depth advanced part which we are going to, of course, going to see. I just said the other way of doing the inter-process communication, skipping the broadcast receiver, but broadcast receiver still make it simple. So that's it for the first part of our SMS reply. We haven't even written even a single user interface, but this part is going to be extended to accommodate a UI and the background service and the broadcast receiver, so that we will go ahead and create a SMS replier application. Tomorrow I'll start creating the UI for my SMS replier application. So tomorrow maybe I'm again going to talk more on the activity. Then I will go ahead and create my broadcast receiver so that I can capture my incoming SMS. And the third, I will see if anything I need to do behind the screen, because the broadcast receiver works in a short span of time. What if I need to search the phone book, get the number, get the name of the particular caller or SMS sender? It's going to take a longer time. So the broadcast receiver cannot work for a longer time. So what I'll do, from the broadcast receiver, I transfer my job to a service. The service will in turn do a searching and all the stuff in the device, and it will come to know whether it's a new number or already existing number. It will also validate the number digit, it's containing a number digit or just a special number such as 4 or 5 digit number, or it will also verify whether the reply is coming from another SMS replier or something else. So it will take some time to validate that particular thing, then reply. So this internal processor, we are going to extend it in forthcoming sessions. Then at one point of time, we will complete the SMS reply. Okay, so instead I'll stop with this.